Okay, this is the homework for Module 1, Lesson 1 of Engage New York, and I want to show you how to do it. One of the reasons that we are multiplying and dividing using the place value chart rather than a standard algorithm is so that they understand, especially when multiplying by tens, hundreds, and thousands, the place value that each of those indicates. So I'm going to go ahead and fill in the place value for each of these. And what I hope kids understand is that anything to the left of the decimal is a whole number, ones, tens, hundreds, and thousands. And anything to the right of the decimal is less than one, or tenths, hundredths, thousandths. And if we have the number 4.582, or 4 and 582 thousandths, and we multiply that by 10, then what we are doing essentially is each digit is moving one place value to the left. So 4 ones becomes 4 tens, or 40. 5 tenths, when multiplied by 10, becomes 5 ones, or 5. 8 hundredths becomes 8 tenths, and 2 thousandths becomes 2 hundredths. So 4 and 582 thousandths times 10 equals 45 and 82 hundredths. So when we are multiplying the next problem, 7 and 281 thousandths times 100, instead of moving one place value to the left, they are going to move two place values to the left. So I'll start by putting the number in the place value chart. And I want to line up each digit in the correct place value. So 7 ones, 2 tenths, 8 hundredths, and 1 thousandth. And if I'm multiplying times 100, I'm moving the digit two place values to the left. It can also be thought of as moving the decimal to the right. If I had 7.281 and I multiplied times 100, I could say, oh, I'm moving the decimal to the right. Oops. Moving the decimal. Let me change the color to show you more clearly. Moving the decimal to the right, two place values. And it would become 728 and 1/10. So that's a way that I know that I grew up learning, is moving the decimal. And one of the things that they're trying to convey is that the decimal is pretty solid. It doesn't usually move too much. And the thing that actually moves are the digits. The digits are the ones that are changing value. So 7 ones becomes 7 hundredths. What used to be 2 tenths when I multiply times 100 becomes 2 tens, or 20. 8 hundredths becomes 8 ones, and 1 thousandth becomes 1 tenth. So they really want the kids to understand the value of the digits that change when multiplying or dividing by 10, 100, and 1,000. Okay, so this translates to when we're dividing. When we're dividing a number like 2 and 46 hundredths by 10, the digits are going to move to the right when we're dividing. And if we're dividing by 10, they're going to move one place value to the right. If we're dividing by 100, they're going to move two place values to the right. So this first problem is done for us. So let's take a look at B. If we have 678 and we're dividing by 100, each of these digits is going to move over two place values. So this 8 ones becomes 8 100ths, 7 tens becomes 7 tenths, and 6 100ths becomes 6 ones. So your answer is 6.78, or 6 and 78 hundredths. If we're dividing by 1,000, of course, let me see if I can shift this picture. If we're dividing by 1,000, then these numbers are going to shift three place values to the left because there are 3 zeros. Right? So 1, 2, 3. The 7 goes over here. The 6 that used to be in the tens place, 1, 2, 3, comes over here and is in the tenths place. Oh, wait a minute. Sorry, that's hundredths. This is the hundredths. This is the tenths. and the 7 became the thousandths. But now we have this space here. And after a decimal, we can't just have a space. We'll have to fill that with a 0. So 67 divided by 1,000 becomes 0.067 or 67 thousandths. When we're looking at this last question, how and why the value of the 6 changes in A, B, and C, they're looking at the 6 here was in the hundredths place and ended up in the thousandths place. The 6 here was in the hundreds place, ended up in the ones place. And the 6 here was in the tens place, and ended up in the hundreds place. So what they're looking at is an overall, did the value increase or decrease? The value of the 6 tens in this one became 6 hundredths, so it's much, much smaller. So the value of the 6 decreases. And I would add that in A, it decreased by 10, and in B, it decreased by 100, and in C, the value decreased by a power of 1,000. So that's an important distinction, that they didn't just decrease a little bit, they decreased by a power of 10. Okay, hope that was helpful.